start somewhere with it. All right. So it said that angle B is congruent to angle H and angle F is congruent to angle G. These are what we call our givens. You should have already marked them. Then E is the midpoint of DH. So based on what we know as a midpoint cuts a segment in half. It's its halfway point. That means segment DE and DH are congruent as well. All right. So if this were a proof, we would say DE is congruent to HE by the definition of a midpoint, because that's literally what a midpoint means. It cuts a segment in half. Now, the goal here was to prove that triangle FDE was congruent to triangle GHE. So, yes, we only need 3 congruent parts, and we have that. All right. And the postulate that we proved it by was which one? So it's side, angle, side, angle, side, angle, 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 side. No, it was angle, angle, side, yes. All right. So remember, we have 2 angles that were congruent, so it had to be either angle, angle, side, or angle, side, angle. All right. But the side is what told us it was angle, angle, side. Remember, angle, side, angle, the congruent side has to be where? It has to be between the 2 congruent angles. All right. This one is only next to one of the angles. It's not between them, so it has to be angle, angle, side. All right. That's how you tell the difference between the 2. We can't we can't assume that these 2 are congruent because they're not quite vertical. They're more so linear. They're like a linear triplet with this angle right here. So we can't really assume that they're congruent. Now, since we know that they're congruent triangles, now we can assume they're congruent. But until we could say a postulate, we can't assume these 2 are congruent. So. Now, this is what we call kind of a flow proof. All right. So you already had your 3 congruent parts. So that DH were congruent, F and G were congruent, and side DE and DH were congruent. Because of that, we can assume that those 2 triangles are congruent. Now, what they mapped out in red here is what we're going to be doing a lot of today, which is proofs. Now, this is a specific type of proof called a flow proof, meaning if we have this information, that means it leads us to this, which then leads us to this, and so on and so forth. So you guys know those old cop shows where they got like the cork board and they have like all the string going everywhere, how everything connects? It's kind of like that. All right. So typically what would happen is we start with our given. So that was the midpoint and these 2 angles were congruent. Now, from the midpoint, we can conclude that those 2 segments were congruent because that's what the definition of midpoint means. And because we have all this information, we can conclude that the triangles are congruent by angle, angle, side. All right, so with proofs, we have our statement, which we'll get more into in a minute, and then our reason, which is why that statement makes sense. All right. And then lastly, how do we know that side FD and GH are congruent? Well, we already proved that the triangles are congruent. So obviously, if we have 2 congruent triangles, then those 2 sides, corresponding sides, have to be congruent. So remember last week when we talked about CP/CTC? Congruent parts, congruent triangles are congruent. If it's in a proof, that's what you would state if it asks us to prove that 2 sides were congruent. So sometimes in proofs, they'll say, okay, here's 2 triangles. I give you this, this, and this. Now prove these 2 sides are congruent. First thing you'd have to do is prove the triangles are congruent first, because once you do that, you can state that those 2 sides are congruent by CP/CTC. All right. All right, here's the quick notes. Where? Uh, Hearts. Sorry. It's not my handwriting. I don't know what it was. All right, here's your quick notes. So write these down quickly and then get out that green sheet of paper. So once you finish, have your green sheet in front of you and you can put your journal away. All right, does anyone need more time copying? All right, one more minute. All right. So what we're going to do now is kind of an intro to the proofs. That before we actually start doing some actual proofs, we're first going to go over the different types of statements and reasons that you will typically use. All right. So when it comes to proofs, there are two types we're going to talk about. There's the flow proof, which is what we kind of just did with the mathematic, and then there's the two column proof. All right, they're pretty much the exact same thing, just different formats. All right, but what they both have in common is that when you're making proofs, you always have to have a statement, which is kind of like a claim. So these two angles are congruent, or these two sides are congruent, or these two sides are parallel, or whatever. And then your reason, which goes along with the statement. So these two sides are congruent because the midpoint theorem, or these two angles are congruent because they're vertical. There's always a statement with a reason. All right. So in mathematics, you can't just make a statement and assume it's true. There's got to be evidence to back it up. There's always a theorem or a property or even just a calculation where that would make sense. All right. Now, geometric proofs are some of the easier proofs. You will see them again in Math 3, but instead of with triangles, you'll see them with quadrilaterals. All right. So getting fairly good at proofs now will definitely help you later in Math 3. All right. How do I know? I also teach Math 3. So I do know it will come back and watch you again. All right. So on that green sheet of paper, there's a list of just different types of reasons that you will see. So these are what you would use to help you ratify a statement that you make. So I would read through these on your own because we're going to also write down some on our own. So this is just kind of some that you may see. So for example, reflexive property. We talked about that last week. Which, remember, the reflexive property means that essentially if two triangles share a side, that side that they share is congruent to itself. All right. Complementary angles, some of them 90 degrees. Supplementary angles, some of them 180, so on and so forth. So you may see these in some shape or form when you're doing proofs. Because honestly, there's not always one general way to do a proof. There's a lot of different ways you can prove different things. Now, on the back is a table that looks like this. So this is what we're going to be filling out together. This kind of puts more into words or puts more into a visual aspect of what you saw on the front of that paper. These are also the most common ones that you'll use with triangle proofs. All right. So the first one, we have two intersecting lines. We have angle 1, angle 2. So based off this diagram, what do you think my statement would be? So what would I say about these two angles? They're congruent. All right. So angle 1 is congruent to angle 2. Now, why are they congruent? They're vertical angles. So the reason is that vertical angles are congruent. All right, so we don't just say that they're vertical angles. That's implied. We have to say that vertical angles are congruent. All right. So we can't just say, oh, it's because they're vertical angles. No, we have to say, well, mathematically speaking, we know that vertical angles are congruent, so they have to be congruent. All right. Now, let's say I have a triangle like this. I'll call it A, B, C, D. And I'm going to say that AC is congruent to AC, or we can state it as AC is congruent to CA. Now, that's one way you might see it, this particular property. Another way you might see it is if you have a picture that looks like this. Let's call this E, F, G, and then this segment will be HJ. And I'm going to mark this angle right here, and I'm going to say that angle E is congruent to angle E. Now, this is something that we've already talked about before. What property do you think I'm talking about here? I said it like 5 minutes ago. Not the midpoint. So I'm saying that this side is congruent to itself, and this angle is congruent to itself. So another way you might see this is angle HEJ is congruent to angle FEG. So I'm saying that this side's congruent and this angle's congruent. What property lets me do that? The reflexive property. So reflexive property means that any side or angle that two triangles share can be congruent to itself. So these two triangles right here, the small one and the big one, both share angle E. These two triangles here share this little segment between them. All right. So by the reflexive property, we can assume that the two sides dash angles are congruent because obviously it's with yourself. Yeah, you're congruent to yourself. All right. Any questions on that one? Now, little review from last week. Have two sets of parallel lines cut by a transversal. All right. I'm going to have angle 1 here, angle 2 here. What statement can I say about these two angles? So that's not the statement. Alternate interior would be the reason, or part of the reason. But what would I claim? Would I claim they're congruent, supplementary, cut states in half? What do you think? We would say that they're congruent. So our statement would be angle 1 is congruent to angle 2. And then the reason would be because alternate interior angles are congruent in parallel lines. All right. So your statement is what you're claiming about them, and that typically deals with congruency, whether they're parallel or supplementary, whatever. All right. Your reason is the why. All right. So your statement's the what, your reason's the why. All right. So two more parallel lines. But this time I'm looking at angle 1 here. And angle 2 here. So what can I say about angle 1 and angle 2? What would the statement here be? They're supplementary. So the way that we would state this is there are two ways. We can either flat out say angle 1 plus angle 2 is equal to 180 degrees. Or we could say angle 1 and angle 2 are supplementary. All right. So either one of those two statements you can make. They're pretty much the same thing, just written differently. Now, why are they supplementary? What makes them supplementary? They're same side interior. Same side interior. Angles are supplementary. All right. One more set of parallel lines. Let's say this is angle 1, this is angle 2. What statement could I make about those two angles? So look at their placement specifically. Well, they're corresponding, but that's part of the reason. But what's true about corresponding angles? They're congruent. So our statement would be angle 1 is congruent to angle 2. And then the reason would be what Amelia said, which is corresponding angles in parallel lines are congruent. And guys, I'm using the symbols for these just a shorthand. So save you some writing time. Make sure you know angle, parallel lines, congruent symbols, what they are. All right, so moving away from the parallel lines, all right? Don't forget, you may also see alternate exterior and same side exterior as well, but they're pretty much the same thing as alternate interior and same side interior, all right? But we're not going to actually write that down. All right, now we're going to talk about the congruent triangle postulate. So we're going to review the congruent triangle postulates from last week. All right, so I got two triangles. Then I got my little congruent tick marks. And my statement will be that triangle ABC is congruent to triangle DEF. Why are these two triangles congruent based off of what I marked? What postulate lets me know that these two triangles are congruent? Side, side, side. So we would state that these triangles are congruent. Side, side, side makes them congruent. If I do another one, so still doing A, B, C, D, E, F, but now I'm going to mark different parts. So I'm going to do this and this. And I'm stating again that triangle ABC is congruent to triangle DEF. So guys, for the next couple ones, the statement's going to be the exact same thing. All right. The only thing that's going to change is the reason. So, based off of what I just drew, what's the reason those two triangles are congruent? What postulate? Side, angle, side. So we have two congruent sides, congruent angle between them. So SAS, and it's congruent. Any questions so far? So we're just reviewing what we talked about last week, essentially. All right. Same two triangles again. So ABC, DEF. But this time, These are not my best triangles, but you know what? It's fine. And I'm saying that these two triangles are congruent again. Why? Angle, side, angle. So I have two angles with a congruent side in between them. All right. Two triangles again. Still naming them exactly the same. But now I'm going to mark it like this. I'm still claiming that they're congruent. Why? These two are congruent, but why? The postulate. Angle, angle, side. So I have two angles that are congruent, and then the side that's not in between those two angles. All right, my last congruence postulate. These triangles are a little different. I'm making them two right triangles. I'm still going to label them ABC. A, B, C, D, E, F. Same with these two. All right. What makes those two triangles congruent? So these triangles are still congruent. Not side angle because spelled backwards, that's ass. And we don't want asses in class. Yes, I said it. I'm not saying it again. Now, it technically is side angle, but there's a special name for it specifically. Say it again? HL. What does HL stand for, though? Hypotenuse leg. All right. So remember, this is the only case of the but word that works. All right. So it's only when it's a right triangle and one of the legs is congruent and one of the hypotenuse is congruent. All right. That's the only form of buts that we want. If it was any other triangle besides a right triangle, it doesn't work. All right. Almost done. So the next one is just if we're talking about any kind of congruent triangles. So we can say angle 1 is congruent to angle 2, or side AB is congruent to side DE. Now, we can claim after we've proven congruent triangles that any side or angle that's corresponding to each other are congruent because of CPCTC. But again, we can only use this after we prove congruent triangles. Now, if you don't remember exactly what that means, it just means that congruent parts of congruent triangles are congruent. All right. We just shorthanded the CPCTC, which you think that's actually a little bit longer, but that's what it is. So sometimes with proofs, they may ask us to prove that two sides are congruent. Well, the first step is to prove the triangles are congruent, because then You only have to make one more statement after that, and that's that those two sides are now congruent because of CP, which, logically that makes sense. If you know that triangles are congruent, obviously the two corresponding sides of triangles have to be congruent. All right, that's just logic. All right. All right, almost done, guys. So now we have this triangle here. It's cut by, let's say, this line. We're going to call this N, M, dash W. Well, actually, no, we're going to call this line M, this line N, but we're going to make, this is the point W, X, shoot, that's Y, X, Z. So it's hard to tell, but remember, I use lowercase letters for lines. So I'm naming line N and line M. So these two lines right here, right? That's why I send them when it has their points. And I'm going to state that M, what does that symbol mean? So I said M is something to N. What does that symbol mean? Perpendicular. All right, so that symbol means perpendicular. So if they're perpendicular, we can state that angle WXY and angle WXZ, so these two angles right here, are right angles. And why? Well, it's because perpendicular lines form right angles. You guys already knew that about perpendicular. You know that if two lines are perpendicular, they form a right angle. All right. All right, we're essentially going to draw the same picture for the last one. So this is line M, line N, W, Y, X, Z. But this time we're not going to claim that M and N are perpendicular. We're just going to mark that those two angles are right angles. So there are two different statements that you can get from this. The first one is that WXY is congruent to WXZ. And that's just because if they're both right angles, well, all right angles are congruent because they're 90 degrees. All right. If you ever see two right angles marked, you can automatically prove they're congruent because they're right angles. The last thing that we can make is angle WXY and not angle, triangle, and triangle WXZ are right triangles. And the reason is the triangle contains a right angle. So all of these are different types of reasons and statements that you may give while you're proving that two triangles are congruent. All right. And there may be more that you use. but these are the general ones that you'll see a lot of. All right. So leave out your graphic organizer because you may want it for this next part, but take out that packet of problems that I gave you guys. So that packet is actually a print off from Delta Math, mainly because this is going to be your equivalent of a Delta Math for this one, mainly because it's easier to do on paper than it is to try and do it online. All right, but Delta Math has some really good proofs that we wanted to look at. So we're going to do a couple together, and then I'm going to have you try some on your own, and then I'll give you some as homework. All right, but we're going to be taking today and tomorrow and possibly Wednesday on proofs alone, because proofs can get, it may sound relatively easy now, but they can get a little dicey sometimes. All right. Any questions on the reasons and statements? All right. So we're going to look at number 1 together. So we're going to determine if the two triangles are necessarily congruent. If so, fill in the flowchart proof to prove that they are. So first off, just at first glance, do you think these triangles are congruent? Yes. Yes. So we're claiming that yes, they are congruent. Now, whenever you start a proof, you always start with what's given. So you always list what's given. And what's given to us right now is what's already marked. All right, so for each of these givens, I need to basically state what's already marked. All right, so sometimes they flat out say given blah, 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 or sometimes they just have it marked for you already. So what will be one given statement that I can make based off of what they marked? So not just right angles, but they are right what? Triangles. So we're saying that triangle EDF and triangle RSP are right triangles. And our reason is simply that it was given to us. Because we had that right angle, it was given to us. You don't have to say a statement about it. If it was given to you, that's your reason. It's given. Yes. So, say it one more time. We can't claim that because it's not marked. We're going off the base of what's marked. So DE, you mean, right? Yeah. So DE and SR are congruent. We can state that because it was given. So DE is congruent to SR. And again, the reason, it's what's given to us. All right, there's one more that's given from what's marked. Sutton. EF is congruent, I'm going to say RP, because we want to make sure it's the corresponding. And again, it's because it's given. So, the easiest statements you can ever make in a proof are your given statements. All right, that should always be the top couple of statements on your proof. It's whatever's given to you. Now, this one's pretty easy because based off of that information, we can already claim that the triangles are congruent. So we can say that triangle EDF is congruent to triangle RSP. Now, what postulate tells us that these two are congruent. So they're right triangles. Hypotenuse leg, good. So the two hypotenuses, or hypotenuse, I don't know what the form that is, are congruent. Two of the legs are congruent. So we can claim that they're congruent because hypotenuse leg. That's all we would have to state. So this one was a relatively easy proof because basically we were already given everything. We just had to state what postulate made them congruent. All right. All right. You guys want to do another one that's similar to this, or think you're okay with the simple one? Okay, try number 2 on your own. So it's very, very similar. We're going to say that they are congruent. Now tell me what all the givens are, and then tell me the postulate that makes them congruent. So you're just stating what was given to you. So look at what's marked. Basically restate what's marked. Word for. By the way, guys, just something with notation and delta math. If you see an angle with these tick marks on it, that's the same thing as drawing like the 2 lines or just the 1 line. So just match the ticks. Okay. All right. Thumbs up if you're ready. It's pretty quick. All right. So someone raise your hand and tell me one statement that you can make based off of what's given. Angle A is congruent to angle K. Now, it doesn't really matter the order that you put it in as long as it stays somewhere. Yeah. So as long as you got angle A is congruent to angle K somewhere, you're good. What's another one? Angle Z is congruent to angle L. Good. And there's one more. What is it? Good. Line ZA is congruent to LK. So we've stated everything. So now we can say that those two triangles are congruent because of what postulate? Angle, side, angle. So that's exactly what I got. All right. Now, yours doesn't necessarily have to be in the same order as mine. If you wrote these statements down, it doesn't matter which box you put them in as long as they're written down. Okay? All right. Any questions on the really, really basic ones? All right, now we're going to look at one that's not necessarily, we're just given everything. All right, so we have to make some conjectures. So look at number 4. So we're going to do this one together. Now, this is one where they gave us a couple of things, and then we still got to make some more conjectures to figure out what's going on. All right. So, whenever you do givens, if it's not already marked, make sure you mark it. All right. So they said that given AC is an angle bisector of angle BAD and BCD, we need to complete the flow chart. All right. So this line right here is an angle bisector. Who remembers what angle bisector means? What does it do? Well, they share a line first off, but what does an angle bisector do? If a line bisects an angle, what happens to that angle? It gets cut in half. All right. So what this angle did is it cut angle A in half. Now, they already gave us our givens, which was angle AC bisects angle BAD. That was given. And angle AC bisects angle BCD. And again, that was given. So they already wrote out our given statements for us. Now, they gave us our statements already. Our job for this one is to write out the reasons. Okay? So given that angle AC bisects angle BAD, they're stating that angle BAC is congruent to angle DAC. So if I come up here to mark it, they're saying angle BAC, so this one right here, is congruent to angle DAC. So this one right here. So they're saying those two angles are congruent. Why? Because it did what? Because the angles will just cut in half. So there's two ways you can state this. One, you could say that's the definition of an angle bisector. Or you could state it as angle bisector cuts angle in half. All right. So more often than not, you'll say the definition of an angle bisector. But another way you could state it is an angle bisector cuts an angle in half. Which that's the actual definition of an angle bisector. All right. Now, they then say, because AC bisects BCD, that angle BCA is congruent to DCA. So they're saying that angle BCA, so this one right here, is congruent to DCA, so right here. What's the reason for that one? It's the definition of an angle bisector, again. So if you notice, our given statements, they have arrows that draw to them because they connect. So if they're saying that this line bisects this angle, then our reason probably has to do with what they gave us originally. All right. So again, this is because that's just the definition of an angle bisector. Now, This last statement did not come from our given, but we have enough information to conclude this. So we're saying that side AB is congruent to side AD. Now, they said that side AB is congruent to side AD. Now, did they already mark that for us? Yes. So since they already marked it for us, we can say that the reason is it's what? Given. If they already marked it, it's given. All right. So typically with proofs, guys, they will not mark anything for you unless they intend to give it to you. So if it's pre-marked for you, it's given. So based off of all that we've marked, we can conclude that the two triangles are congruent by what postulate? Based off of what we marked alone. Say it again. Not the bisector. What congruence postulate tells us those two triangles are congruent? Not angle side angle, but angle angle side. All right. So we're not taking into account the reflexive property here. We're going off of based on what they marked as congruent. All right, which was these two angles and a side that's not between them. So we have to say it's angle angle side. Now, if they didn't mark those two sides, we could have used the reflexive property. All right, because and then it would have been angle side angle. So like I said, there's more than one way to kill a duck. All right. That was a really weird statement, but you know it's fine. So based off of what the information we have, angle, angle, side. And again, we just have to go off of what they gave us alone. All right. So now we're going to do one where we actually have to write out some stuff. So go to number 6. This will be the last one that we do today. So here's our picture down here. And we're going to do now not a flow proof, but a 2-column proof. So pretty much the same thing as a flow proof, except instead of seeing where the arrows connect, you're just writing out your statements with their reasons next to them. All right? It's just like a T-chart, essentially. So we're going to prove that these two are congruent. So the first thing they already did is they just already told us our given statements, which was side AB is congruent to CB, and DB bisects angle ABC. So they told us that these two sides were congruent, and they already marked it for us. And they also told us that DB bisects angle ABC. So it bisects this angle only. Now, what do you think the next statement I can make is? So my recommendation when you're doing these is think about what one of your given statements is and see if you can make a statement based off of that given statement. So think about the flow chart. So we have our flow chart. All right. We said that AB is congruent to CB. That was a given. We have that DB bisects ABC. All right, and again, they're given. Now, we may or may not be able to make another statement based off of what's given. All right. So, do you think I could make any other kind of statement based off of the segment congruency? Anything else I can draw from that? Yes, no, maybe? No. All right, so that will probably just kind of lead into our congruent triangle part. What about this? Could I make any kind of congruency statement based off of this statement? Yes. What would that be? Say it one more time. Right. So we're going to use the whole 3-letter thing. So we're going to state that angle ABD is congruent to angle CBD. All right. So angle ABD is congruent to angle BCD. And what can we state about that? Why are they congruent? It's the definition of an angle bisector. All right. So we used what they gave us here to draw this statement. So we concluded that angle AED was congruent to angle CBD. So one more time. Angle B equals angle D? No, we can't conclude that based on the information we're drawn. All right, now we kind of dealt with all that we have with our givens, but we still don't have quite enough information that these two triangles are congruent. So based off of what we have so far, we have a set of congruent sides and a set of congruent angles. What's one more statement that I can accurately say is congruent because of the information that I know? Say it again. Line PD is what? Congruent to itself. All right. So they share this side right here. So we can say that based off of that, that side BD is congruent to BD. Why? The reflexive property. So that was just one that we had to draw on our own. It wasn't necessarily given, but given the picture, there's enough information that we could draw from that. We know that since they shared a side, we can assume it's reflexive property. Now, we have enough information to say that these two triangles are congruent. So triangle ABD is congruent to triangle CBD. All right. What postulate tells us that? So based off of what we marked, what postulate tells us those two triangles are congruent? Side, angle, side. You got two sides that are congruent with an angle in between them. Now, we're not done because it then asked us to prove this. But we now have enough information to prove that angle A is congruent to angle C. So they're saying that angle A is congruent to angle C. That's what we want us to show. Why can we now say that angle A is congruent to angle C? Because the triangles are congruent, but what's what we put? What's the acronym? Is that really CPCTC? So those two are congruent because of CPCTC. So since we proved that the triangles are congruent, we know that all their corresponding parts are congruent. All right, we're going to do some more practice with this tomorrow, but just for tonight, just so you guys got some more practice, I want you guys to try numbers 3, 5, and 7. All right, so try 3, 5, and 7 on your own. So just 3 problems tonight.